All right, let's implement the quick sort algorithm. In the sort method, there are a few things we need to do. First, we need to partition this array. As part of partitioning, the pivot, which we assume is the last element in this array, is going to move to its correct position. Then we get the position of the pivot, and from there, we'll recursively sort the left and right partitions. So, sort left and sort right. That is the basic idea. Let's start implementing the partitioning algorithm first. So, we need a separate method for that. A private method, because we don't want to call this from the outside. So, private integer partition. This integer that we're returning here is the index of the pivot after it's moved to its correct position. Okay, so we pass our input array here. Now, in this implementation, we assume that the pivot is the last element in this array. So we set pivot to array of array.length -1. We also need a variable called boundary. Initially, we set it to -1, which means the left partition is empty and the right partition starts from index 0. Now we need to iterate over this array. If we find an item that is smaller than the pivot, we need to put it in the left partition. And to do that, we're going to increment the boundary and then do a swap. That is super easy. So we need a for loop. For I, we set it to 0. As long as it's less than array.length, we increment it. Now, if the current item, so array of I, is less than or equal to the pivot, here we need to increment the boundary, so boundary ++, and then we need to do a swap. Now, to save time, I'm going to go to our bubble sort class and copy the code for swapping two items. Let's paste that over here. So we increment the boundary and then call the swap method. We pass our array. We need two indexes here. One is the index of the current item, and the other is the index of the boundary. Now we can combine these two lines and make our code cleaner. So let's remove this line. First, we increment the boundary and then do a swap. Now, because we have a single statement here, we don't need these curly braces anymore. So that is a better and cleaner implementation. So after this for loop, the pivot will move to its correct position, and finally we'll return the boundary. This will be the index of the pivot after it's moved. Now, back to our sort method. So we're done with the first step. Let's call the partition method and pass the array. We get the boundary. Now we need to recursively sort the left and right partitions. Now, as I told you in the last video, with quicksort, we don't need to allocate new subarrays. We can do all this partitioning and sorting in place in the original input array. So here we don't need to copy all the items from index 0 to boundary into a separate array. Instead, we're going to add two parameters here, start and end. These two parameters determine what part of this array we're trying to sort. As we recursively call this method, these indexes will change. For example, initially, let's say our array has 10 elements. So we'll pass 0 and 9 as the start and end index. Now let's say the pivot moves to index 4. So we'll call this method recursively and pass 0 and 3 as the index of the left partition, and 5 and 9 as the index of the right partition. So here we are assuming that the pivot is at index 4. Okay? So that's the idea. Now let me remove these comments. So we pass the start and end index. Now here, once we get the boundary, we call the sort method. We pass our input array. Our left partition is going to start from here. So we pass the start argument here. And it's going to end just before the boundary. So boundary -1. Because this boundary represents the position or the index of the pivot. Okay? Similarly, we're going to call the sort method, pass the array. Our right partition starts after the boundary, so boundary +1, and it goes all the way to here. So we pass the end argument here. Now here we're calling this method recursively. That means we need a base condition. Otherwise, this recursion is going to go forever until our program crashes. So what is the base condition? That happens when we have a single item or an empty array. So if start equals end, that means we have a single item array. We're going to return. Now, what about an empty array? Well, that will happen when start becomes greater than end. So we should revise this condition to start greater than or equal to end. In that case, we're going to stop the recursion. We're almost done. Now that we're passing these start and end indexes, we should also pass these to our partition method, because we don't want to partition the entire array. We only want to partition the segment that we're working with. So let's pass these arguments here and add 2 new parameters to this method. So start and end. Now we need to make a few small changes here. So pivot is going to be the last element. So we replace this expression with end, because that is the index of the last item in the segment we're working with. Okay. And boundary shouldn't be -1, because we use -1 when the array starts from index 0. But in this case, this parameter determines the start of our array. So we should change this to start -1. So if the segment that we're looking at starts from index 3 and goes all the way to index 8, boundary is going to be 2. Okay. Now, we should also modify our for loop. So instead of starting from index 0, we should start from here and go all the way to the end of the segment. And that means we should add the equal sign here, because end is a valid index. It's not the length of the array. Okay. So we iterate over this segment. If we find a smaller item, we'll put it in the left partition. Okay. Now let's test our implementation. So back in the main class, here we have an array with these items, 7, 3, 1, 5, and 2. Let's use the quicksort class. Now here we should pass the start and end indexes. And this is not ideal because we shouldn't worry about passing these values when we want to sort an array. But we'll come back and fix this in a minute. So for now, let's pass 0 as the start. And here we have 5 items. So the index of the last item is 4. Let's run our program. Our array is sorted. Beautiful. Now, let's go back to our quicksort class. Here I'm going to add a new public method, public void sort, which takes an integer array. In this method, we're going to pass those initial values. So we call this other sort method, which we're going to make private. And then back in the public method, we're going to call sort, give it the array 0 as the start and array.length -1 as the index of the last item. That is better. With this change, we can go back to our main class. We no longer have to pass these values. So the interface of our class is cleaner and easier to use. We simply pass our array and it gets sorted. Beautiful. Now let's test the edge cases. So I'm going to throw in a few duplicates. Let's make sure everything is working. There you go. What if we have an array with 2 items? So far, so good. What if we have a single item array? That is also working. And finally, what if we have an empty array? Beautiful. So this is how we implement the quicksort algorithm.